We've all been there, right? You're using an app and it just crashes out of nowhere. Or you wait forever for a big software update that seems to break more stuff than it fixes. It's frustrating. And it all comes down to a really fundamental challenge, which is exactly what we're going to get into.
I mean, it seems like it should be simple. You just tell a computer what to do. But in reality, building large, reliable software is one of the most complex things we do. That huge gap between a brilliant idea and a product that actually works, well, that gap is just filled with potential chaos.
And a lot of that chaos, it comes from some pretty common myths. People think fixing a bug is just changing one line of code. But in a big system, that one tiny change can create these massive, unpredictable ripple effects. Or there's the idea that software should just work perfectly the first time. Nope. And my personal favorite myth, if a project is late, just throw more people at it. But software isn't built on an assembly line. A new person has to be brought up to speed, and that can actually slow things down at first. So to keep from building a digital house of cards that's just going to collapse, you need a blueprint. You need a structured, disciplined process. You have to stop just writing code and start actually engineering a solution. And that's where this term comes in, software engineering. Now, check out this official definition from the IEEE. Look at those words: systematic, disciplined, quantifiable. This isn't about guesswork or some lone genius coder pulling it all-nighter. It's about applying real, proven engineering principles to the art of creating software. And that's the key takeaway, really. Coding, or programming, that's just one piece of the puzzle. It's the act of writing the code. Software engineering is the whole game. It's everything. The cost estimates, the design, the quality control, the maintenance plan. It's about building something that's meant to be robust and meant to last. The basic blueprint for all of this is what's called the Software Development Lifecycle, or SDLC. Think of it like the master recipe. First, you figure out what you're even building. That's requirements. Then, you plan how you're going to build it. That's design. Then you actually do the building. That's coding. After that, you check if you built it right. That's testing. And finally, you got to keep it running and updated, and that's maintenance. But, just like in construction, you wouldn't use the same blueprint for a skyscraper that you'd use for a garden shed, right? Different software projects have different needs. And so, over the years, we've come up with several different models or game plans for following this life cycle. Way back in the early days, a lot of projects just used the build and fix model. It's exactly what it sounds like. You code something, and then you just keep patching it up until it kind of works. It is pure chaos. So the first real attempt to bring order to that chaos was the waterfall model. It took that life cycle we just talked about and made it a very strict, step-by-step process. And this visual shows its structure perfectly. You have to complete all of the requirements analysis before you can even think about starting the design. You have to finish the entire design before you can write a single line of code. Each phase just flows down to the next, like a waterfall. It's very systematic, but it's also incredibly rigid. There's no swimming back upstream. And that rigidity, well, that's its biggest weakness. Because what happens in the real world? The customer sees an early version and says, oh, hey, can we add this feature? Or, you know what? Let's change that. In a strict waterfall model, there's just no good way to handle that kind of change. So that exact problem led to a whole new way of thinking. The solution was, hey, let's stop treating a project like one giant waterfall, and instead, let's build it in smaller cycles. And this is the whole idea behind what's called the iterative model. The concept here is simple, but it's really powerful. Instead of delivering one massive, perfect product at the very end, you deliver smaller, working versions in cycles. The first iteration might only have a couple of core features. The next one adds a few more. The beauty of this is that the user gets something they can actually use way earlier, and you can adapt to their feedback with each new cycle. Now, the iterative model is great for a lot of projects. But what if you're building software for a flight control system or a medical device? A project where a surprise problem isn't just an inconvenience, it could be a catastrophe. For that, you need a model that puts risk management right at the very center of everything. And that brings us to the spiral model. It takes that iterative idea of working in cycles, or spirals, but it bakes risk analysis into every single one. Before any major development happens in a cycle, the team stops to identify and analyze potential risks. This lets them tackle the biggest, scariest uncertainties first, which makes it a much safer approach for those huge, high-stakes projects. Okay, so we've looked at how to manage a single project, but what about the bigger picture? How does an entire company make sure that all of its projects are run with discipline and quality? How do you actually measure and improve the capability of the whole organization? Well, that's where the Capability Maturity Model, or CMM, comes into play. It was developed by the Software Engineering Institute, and it's not about one specific project model. It's about evaluating how effective and mature a company's overall software processes are. It's like a report card for the whole organization.
CMN lays out 5 levels of maturity, and it really is like climbing a ladder. At level 1, it's total chaos. Success only happens because of individual heroes. At level 2, you have some basic project management, so you can repeat things that worked before. By level 3, there's a standard documented process that everybody follows. At level 4, you're not just following the process, you're measuring it with hard data. And at the very top, level 5, the entire organization is obsessed with using that data to constantly get better. You could think of it like this. Level 3 is a cook who can follow a recipe. Level 4 is a chef who measures every ingredient and temperature for perfect consistency every time. And level 5? That's a culinary scientist who's constantly experimenting to make the process itself even better. It's a journey from chaos to predictable excellence.
So, after looking at all these models and frameworks, from waterfall to spiral to CMM, we land on the real point. There is no perfect model that works for everything. Success isn't about finding some magic bullet process. It's about choosing a structured approach and then having the discipline, as a team, as an organization, to actually follow through with it.